Good morning to all of you. First of all, I welcome in the live lecture which is organized by the Dayanand Science College, Latur. Today, we shall discuss the next part of a metric space which is belonging to the second unit of our curriculum, and the next part, that is a complete metric space. Actually, in the last lecture we have seen that here what is the concept of convergence or the existence of the limit. Also we have seen that the definition of the convergence of a limit. Also we have defined the quasi sequence and today we shall also we have studied the theorem on a quasi sequence, first theorem. Today we shall discuss the next part, that is a complete metric space, which is the part of a quasi sequence. Actually quasi sequence, one student I think asked one question regarding the relation between quasi sequence and monotonic decreasing sequence. Quasi sequence means a sequence having terms closure and closure when that terms goes to the infinity. Means xn minus sn, distance of xn minus xm, which is less than epsilon, okay, for m comma n which is greater than 0. n0 is the any which is greater than n0, where n0 is any positive integer. यानी कि यहाँ पे जो m और n we consider that, see this we shall discuss here. The complete metric space is a metric space which is every quasi sequence is convergent. Okay. In other words, we can say that every quasi sequence in the metric space tends to a limit to a point which is again an element of that space. Means quasi sequence having a limit. Hence the metric space is a sense of a complete. Now we shall discuss the complete definition of the complete metric space. First of all, we shall define the concept regarding the convergence of a limit, convergence of a sequence. If a sequence having a limit, then we can say that it is the convergent sequence. We can define existence of limit in different way, but in the metric space we have to define by using a distance formula. हम अलग अलग जगह पे अलग अलग तरीके से कॉन्वर्जेंस और एग्जिस्टेंस ऑफ लिमिट प्रूव कर सकते हैं, लेकिन मेट्रिक स्पेस में कॉन्वर्जेंस ऑफ लिमिट प्रूव करना है तो हमें डिस्टेंस का यूज करना होता है, डिस्टेंस फंक्शन यूज करना होता है. उसी तरह से हमने डिफाइन किया है. सिमिलरली we have already defined the quasi sequence. Quasi sequence can be defined in different way, modulus way, distance way, but in the metric space we have to define by using the distance function. Now we shall discuss the next part, that is a complete metric space. What is the concept of a complete metric space? We shall discuss here. Write down the definition of a complete metric space. Now definition. Now how to define the complete metric space? We shall discuss this. A metric space, complete metric space. Now definition. Say this. A metric space XD a metric space X comma D is said to be complete metric space, said to be complete if every quasi sequence, if every quasi sequence converges to a point of x. This is important. Actually, here हमने last lecture में one theorem we have proved. What is that theorem? What is the statement of that theorem? Who can tell me what is the statement of all the students who are present in this live lecture? You tell me what is the statement of the first theorem regarding the Cauchy sequence. Means first theorem or statement we have proved that every convergent sequence is a Cauchy sequence. इसका मतलब क्या होता है? अगर सीक्वेंस का लिमिट है, अगर सीक्वेंस का लिमिट एग्जिस्ट होता है, अगर सीक्वेंस कॉन्वर्जेंट है, तो उसे हम कॉची सीक्वेंस कहते हैं. मीन्स डिस्टेंस बिटवीन एनी टू सक्सेसिव टर्म्स एट द infinity, near to infinity, which are equals to about 0, tends to 0, means distance of xn comma xm tends to 0 as n comma m tends to 0. इसका मतलब है एवरी कॉन्वर्जेंट सीक्वेंस कैसे रहते हैं? कॉची सीक्वेंस रहते हैं. लेकिन हम उसको कॉन्वर्सली ऐसा कह नहीं सकते कि एवरी कॉची सीक्वेंस इज अ कॉन्वर्जेंट सीक्वेंस. It may be convergent, it may be or may not be, okay, but this is the complete metric space. इसे हम कैसे कह सकते हैं? A metric space XD is said to be complete if every Cauchy sequence converges to a point of X. जर एखादी मेट्रिक स्पेस कंप्लीट मेट्रिक स्पेस म्हणायची झाली तर त्यात असलेली जी कॉची सिक्वेन्स आहे ती कॉन्व्हर्जंट व्हायला पाहिजे. आणि कुठं कॉन्व्हर्जंट व्हायला पाहिजे? द सेट ऑफ दॅट मेट्रिक स्पेस. म्हणजे समजा कुठलीही, सपोज फॉर एक्झाम्पल वी कॅन से दॅट द मेट्रिक स्पेस 0, फॉर एक्झाम्पल here, if we consider, actually if we consider an example, what is that example? See if the example mentioned here, आता ही कंप्लीट मेट्रिक स्पेस एक्झाम्पल कसं असतं पहा. सपोज इफ वी कन्सिडर अ सिक्वेन्स SN which is equals to 1 upon n, that means elements are 1, 1 by 2, 1 by 3, 1 by 4, dot 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 dot. That means the space of this sequence, इस sequence का space कहाँ से कहाँ तक आता है? here इसमें ग्रेटेस्ट मेंबर जो है इस sequence में 1 है और लीस्ट मेंबर जो होता है 0. बट व्हेन वी कैन से दैट इट टेंड्स टू 0 एज n टेंड्स टू infinity, but infinity is not belonging to this set, therefore domain of this sequence is 0, sorry, we can write as 0, 1. So but 0 does not belonging to this set, so we can write as 0, 1. अभी इसमें 0 नहीं आता है. ये कॉन्वर्जेंट सीक्वेंस है, कॉची सीक्वेंस है, बट दिस सीक्वेंस इज नॉट कंप्लीट बिकॉज लिमिट n टेंड्स टू इंफिनिटी, yes, n टेंड्स टू 0, but 0 does not belongs to this set X. That means 0 does not belongs to capital X. So we can say that this example, that is the first example, Sn n is equals to 1 to infinity, is not complete. Complete होने के लिए क्या होता है? सीक्वेंस तो कॉन्वर्जेंट होना ही चाहिए, नो प्रॉब्लम. दिस इज द इसेंशियल कंडीशन. अगर कंप्लीट कहना है तो सीक्वेंस कॉन्वर्जेंस होना चाहिए, वो भी कॉसी सीक्वेंस होना चाहिए, लेकिन सबसे बड़ी बात यह है उसका लिमिट उसी सेट में होना चाहिए, यानी कि शेयर लिमिट ऑफ दिस सीक्वेंस इज 0, लिमिट ऑफ Sn टेंड्स टू इंफिनिटी दैट इज इक्वल्स टू 0. n टेंड्स टू इंफिनिटी Sn ची व्हॅल्यू 0 असते, but 0 does not belonging to this set. So this sequence is not a complete sequence. So this is not इसी तरह से हम कुछ एग्जांपल्स भी लेते हैं. शेयर we have considered this. Now write down, these are the remarks, these are the notes. You must know. हे तुम्हाला माहित पाहिजे. मी दुसरं एक्झाम्पल पण घेईन वाटलं तर तुम्हाला. सेकंड एक्झाम्पल, सी दिस एक्झाम्पल सेकंड. याच्यातलं एक्झाम्पल परत मी दुसरं एक्झाम्पल घेतो. सी दिस कंप्लीट मॅट्रिक्स स्पेस, एक्झाम्पल सेकंड. Let the sequence an is equals to 1 to infinity, which is equals to 1 plus 1 upon n. If we consider the terms of a sequences, that is 1, आता 1 by 2 plus 1 means 3 by 2, 1 by 3 plus 1 means 4 by 3. अगर if we put here 4, 1, यानी कि 1 minute, सबसे फर्स्ट टर्म कौन सी होते हैं देखो. अगर if we put n is equals to 1, n is equals to 1, 1 plus 1 में यानी कि 2 होता है. इसके बाद में अगर हम कंसिडर करते हैं कि सेकंड 1 upon 2, 1 upon 3, see this, then 2 means 2 plus 3 by 2, then we get next, what is that? We can write as 3 means 4 by 3, dot dot dot, it tends to 1, it tends to 1 means here. But if we consider that is a sequence an, if we consider x is equals to 1 comma 2, then limit n tends to infinity an is equals to 1. Okay, then 1 does not belongs to x, so we can say that this sequence is not complete. हम अलग अलग तरीके से एग्जाम्पल यहाँ पे देखना चाहते हैं. So you can write this, 1 does not belong to x, therefore the given sequence is a quasi sequence but not complete. ये 1 does not belongs to क्यों कहते हैं देखो, अगर n tends to infinity होता है but infinity does not belonging to this set, so 1 does not belonging to this set. Okay, चला next we shall discuss this another set. Okay, see this, write down these remarks. The discrete matrix space X is a complete matrix space. For in this space, a quasi sequence must be constant sequence. It must be consist of single point repeated from same plane on the convergence. So convergence. See this is the discrete matrix space is a complete matrix space x comma d. आपको पता है डिस्क्रीट मैट्रिक्स स्पेस पे एलिमेंट्स कौन से होते हैं, 0 and 1. which are belonging to the set X. So we can say that the metric space in the discrete metric space, it is a complete. For in this space, a Cauchy sequence must be constant sequence. It consists of single point repeated from some place on, and so it is a convergent. त्यामध्ये त्याचा लिमिट असतो. Second, the space, if we consider the second example, what is that example here? The space here, we can say that the space R comma D is a complete metric space. First of all, the convergence in R is the ordinary convergence numerical sequences. You have to write this note. The space R raised to n of all order n tuples with the metric, we have defined this distance of x comma y, which is equals to I is equals to 1 to n xi minus yi bracket square, is a complete metric space. Is a complete metric space. The convergence in this space is coordinate wise. Distance. Distance, if we calculate the distance by using this formula, using this function, then definitely the value of a distance tends to the given set. Suppose this is R raised to n, then the distance D also tends to the R raised to n. So we can say that this is a complete. R raised to n comma D is called as n dimensional Euclidean space. We have already seen this. हे आपण ऑलरेडी पाहिलेलं आहे अगोदर. युक्लिडियन मेट्रिक स्पेस म्हणजे काय हे ते पाहिलेलंच आहे. तर ठीक आहे. एव्हरी कॉन्व्हर्जंट सिक्वेन्स इज अ कॉसी सिक्वेन्स. व्हेरी गुड. मुळेने आन्सर दिलेला आहे. प्रियंका धनुरे, हर्षदा जोशी, साक्षी कदम, इबितवार, फक्त यांचंच कन्सिडरेशन करा. बाकीचे काय फक्त व्हिडिओ लावून झोपतात का? हा ठीक आहे. नेक्स्ट वी शॅल डिस्कस. जे आन्सर देतील फक्त त्यांचंच मी अटेंडन्स कन्सिडर करणार आहे, बाकीच्यांचे नाही करणार. ठीक आहे. नेक्स्ट राइट डाउन नेक्स्ट थेरम. व्हाट इज दैट थेरम्स हियर? See this. Now write down the example next problem, or we can write example. The space, if we consider closed interval 0, 1 of all bounded continuous real valued functions defined on the closed interval (0, 1) with the metric D given by distance of f comma g, which is equals to maximum over 0 is less than or equals to x is less than or equals to 1. The value is mod of, see this, mod of f of x minus g of x. This is the real valued function, bounded of continuous bounded real valued function. Actually we have defined this, or also we have proved this function is a metric space. Actually we have taken this example in the metric space for proof x comma d is a metric. Distance function defined in this way is already we have seen a metric space. Now we have to prove that See the given by prove is a complete metric space. Is a complete metric space. यानी कि आपको क्या प्रूव करना है? सी दिस फंक्शन distance function d which is defined in this way is a complete metric space. ये आपको प्रूव करना है, ठीक है. सो आंसर और प्रूफ we can write this as a complete metric space. आता हे परत पहा, what we have to prove, what we have to do. See this, the space 0, 1 of all bounded continuous real valued function defined on the closed interval 0, 1 with the metric d given by distance of f, g which is equals to maximum of f of x minus g of x is a complete metric space. Okay, actually this is a statement of the problem, or we can write statement of the theorem. We have to prove this function x comma d is a metric, complete metric space. Okay, now we shall solve this theorem. Write down the proof of this theorem. Proof is very easy. आश्रया गोरटे कधी येते का? आश्रया संपल्यानंतर यायचं, कशासाठी उगा अटेंड करते? हां, रेग्युलर वेळेवर येता येत नाही का? Let write down, first write down the proof, then I will explain it. Let the sequence Fn be a quasi sequence in closed interval 0, 1. Consider this sequence is a quasi sequence because to show the complete it is essential that that sequence must be quasi sequence. Now what we have to prove that? We have to prove that the limit of this sequence which is in the 0, 1. So let अगर वो quasi sequence है, if we consider Fn is a quasi sequence, then it satisfies the definition of quasi sequence. अगर हमने इसको quasi sequence consider किया है तो वो quasi sequence की definition satisfy करते हैं. Definition we can take. So for epsilon greater than 0 be given, then there exists a positive integer n0, positive integer n0, full stop there. Say this, positive integer n0 such that, what is the condition? Distance of Fn comma Fm which is less than epsilon for all m comma n which is greater than or equals to n0. इसका मतलब क्या होता है? We have defined this. इसका मतलब m and n are very large. तुम n0, n0 we can write as n0 also. n0 is any integer. If you consider n0 is very very large, then m and n are also greater than m0. This is the method showing that m comma n tends to infinity. एक प्रोसीजर है, m and n is very very large दिखाने की प्रोसीजर है. So इसका मतलब ये होता है, according to the definition, distance of f comma g can be written as a maximum of mod of f minus g. So distance of Fn minus Fm can be written as a maximum over 0 is less than x is less than or equals to 1, which is Fn of x minus Fm of x according to the given distance function. दिलेली कंडिशन आहे पा डिस्टन्स, त्या डेफिनेशन नुसार आपण याला f मध्ये मॉड्युलस मध्ये कन्वर्ट केलं, which is less than or epsilon for all m comma n greater than or equals to n0. यानी कि अभी ये मैक्सिमम है, तो मैक्सिमम हम रिमूव कर सकते हैं, मैक्सिमम ओवर x 0 to 1 है, तो इसका मीनिंग क्या होता है, मॉड ऑफ fn of x minus fm of x which is less than epsilon for all m comma n greater than or equals to n0 and अभी इसकी वैल्यू मैक्सिमम रेंज कहां तक है, सी दिस मैक्सिमम रेंज कहां तक है, 0 is less than x is less than 1. This is a maximum over 0 to 1. So we can take as a fn minus fn minus fn which is less than epsilon for m and n is greater than or equals to n naught, and this is important condition. What is that important condition? For all x belongs to, here also we can write, and for all x belongs to closed interval 0 to 1, x belongs to closed interval 0 to 1. ये किसके आधार पे आया, देखो, see this, we can write, this is the definition, distance of f comma g is equals to maximum over. So this, according to the given condition, this distance, see this distance between f and n, we can define over the maximum modulus which is belongs to, x is belongs to 0 to 1. So we can write in this way also. So this is a shows that according to the, this is the definition. अभी ये क्या है देखो, ये definition है. So by the Cauchy's criteria, so by the Cauchy criteria of uniform convergence, see this, the sequence fn converges uniformly on closed interval 0, 1. आता सिक्वेन्स युनिफॉर्मली कॉन्व्हर्जंट आहे 0 आणि 1 मध्ये, आणि स्पेस सुद्धा दिलेला आहे 0 आणि 1 मध्ये. therefore f has a limit suppose, therefore the f has a limit which is uniformly continuous in 0, 1. आणि त्याच सेट मध्ये जर लिमिट एक्झिस्ट होत असेल, कंटिन्युअसली एक्झिस्ट होत असेल, सो वी कॅन से दॅट दिस इम्प्लाइज दॅट hence the Cauchy sequence, hence the Cauchy sequence fn converges to a point of C 0, 1 closed interval 0, 1. C means set complex असेल तो 0, 1, and henceforth किंवा hence it is a complete, hence it is complete. दिस इज द युनिफॉर्म कंटिन्युटी. खूप सिंपल आहे, प्रॉब्लेम काही अवघड नाही, खूप महत्वाचा प्रॉब्लेम आहे. ऍक्च्युअली दिस इज व्हेरी इंपॉर्टंट प्रॉब्लेम, बट इट इज आल्सो वेरी सिंपल. कैसा लिखना है, सबसे पहले आपको कॉची सीक्वेंस कंसिडर करना है एफ एन. अगर आप एफ एन कॉची सीक्वेंस कंसिडर करते हैं सीधे, हाँ एफ एन कॉची सीक्वेंस कंसिडर करते हैं, अगर एफ एन इज अ Cauchy sequence, then definitely according to the definition of a Cauchy sequence you can write, for given epsilon greater than 0 there exists a positive integer n0 such that distance of xn comma xm, but here we have given function, so distance of fn minus comma fn which is less than epsilon, but according to the definition distance can be represented in the modulus form. So maximum over 0 to 1 Fn minus Fm which is less than epsilon for all m comma n greater than n naught. Now see this. इथं ओके. तर आता या ठिकाणी पहा, this maximum over 0 to 1, that means we can write as Fn minus Fn which is less than epsilon for m comma n which is greater than n naught, greater than or equals to n naught, and this is over this modulus, this distance function, this length Fn and Fn ची length, actually modulus म्हणजे सुद्धा length असते रे, तुम्हाला माहित राहावं. मॉड्युलस म्हणजे सुद्धा डिस्टन्स, ॲब्सोल्यूट मीन्स द डिस्टन्स बिटवीन टू पॉइंट्स, म्हणजे याचा अर्थ डिस्टन्स बिटवीन टू फंक्शन्स ॲट एक्स विच इज लेस दॅन इप्सिलॉन फॉर ऑल एक्स बिलॉंग्स टू क्लोज्ड इंटरवल 0, कारण दिस इज अ मॅक्झिमम 0 to 1. एक्सची व्हॅल्यू आपण कुठून कुठपर्यंत घेऊ शकतो, मॅक्झिमम 0 to 1 मध्ये. मग ही कंडिशन, ही डेफिनेशन कशाची आहे, mod of xn minus xm which is less than epsilon, म्हणजे ही जी डेफिनेशन आहे युनिफॉर्म कंटिन्युअसची डेफिनेशन आहे. मग दिस फंक्शन इज यूनिफॉर्मली कंटिन्यूअस इन क्लोज्ड इंटरवल 0 to 1. सो इसका मतलब ऐसा है, सो बाय द कॉचीज क्राइटेरिया ऑफ यूनिफॉर्म कॉन्वर्जेंट द सीक्वेंस Fn converges uniformly on 0 to 1. So F has a limit which is uniformly continuous in 0 to 1. Hence the Cauchy sequence Fn converges to a point of C set, means C we have considered according to the given statement 0 to 1, and hence it is a complete. Okay, इसी तरह से ये हमारा यहाँ पे प्रूफ होता है. तो ठीक आहे. तर आता आपण जो नंतरचा पार्ट आहे, परत 2-3 प्रॉब्लेम्स आहेत या टाईपचे, तो आपण उद्याला घेऊ. या ठिकाणी आपण थांबू. काही अडचण आली तर विचारा. चला, सर्वांनी प्रेझेंट राहणं खूप गरजेचं आहे. प्रेझेंटी तुमची त्यावरच पाहिली जाईल. परत 4 वाजता तुमचं मेकॅनिक्सचं लेक्चर होईल. ओके, नमस्कार.